In this presentation, I'm going to talk about stimulation, so for IVF. From all the data that are going to be presented, I removed the young heifer portion. This presentation initially was one I gave at the AETA this year, but that was completely revamped. And I think to start, one of the very important things Dr. Castro mentioned before is that for every single strategy, there is a context behind. And so I'm going to start explaining you the context we are working in. So this is the data from our laboratory in Canada with the donors we are housing. Also, we do work with elite genomic Holstein donors. And the goal of the genomic selection and genomic industry right now is, first of all, to produce the highest number of embryos within a defined period of time. But it's not all about quantity, because another common, I would say, limiting factor that we have is recipients availability. Because we do not always have recipients to transfer these embryos, we need to be able to freeze these embryos. So these embryos need to be of good quality enough to be frozen, and that's the second key element. Then speed would be the last part, because for the genetic gain, the younger, well, I would say the more often we can collect these donors, so the more opportunities the breeders have to create the offspring with the best genomic as possible they can. So these are the three elements to keep in mind: quantities of embryos, quality of these embryos within a short period of time. So I would say big disadvantage of the stimulation Dr. Castro mentions are the fees of the stimulation. And it's not only the cost of the foltropin, because you've got to prescribe these drugs, make these schedules, put the drug in the syringes, having someone giving the syringes. So there is a whole setup going with that is quite expensive. But in our context, the benefit in terms of embryos, in terms of especially of quality of embryos, I would say compensate for all these fees. And under our condition, it becomes cost-effective. So I will suggest to justify a little bit more the use of foltropin, going back to some basics in terms of physiology of the follicular growth. So here on this graph, here that would be day 0. So day 0 would be here. So day of ovulation in a normal cycle. A cohort of follicle is recruited usually the day before ovulation, and will start growing under the effect of FSH. Then one of these follicles will deviate at about 7 millimeters and become dominant. At that time, it starts releasing inhibin that will prevent the other follicles from growing. And at the same time, this follicle will acquire receptors to LH, so this follicle can continue its growth under the effect mostly of LH. Then, if in the presence of a corpus luteum, this follicle will then be undergoing atresia, and a new cohort of follicle, a new follicular wave, will emerge somewhere around day 10, depending on if this is a 2-wave or 3 waves, it can vary it, but well, this is the principle everybody knows. This number here of follicles per cohort of follicles is quite constant, so from one follicular wave to another, and all over the life of mature donors. So we talked about recruitment, selection, dominance, and then atresia. The next thing I'd like to mention is that once the follicle becomes dominant, there is a defined period of time you can take this oocytes and fertilize it. So it's this is a window of competence. Too early, and you won't be able to fertilize it. Too late, same thing. Too late is too late. So there is in our system a defined period of time. You are able to collect these oocytes to have a great chances to get them fertilized and developing into good quality embryos with high chances of success in terms of pregnancies. So the principles of stimulation we are applying, we're usually working on the second follicular wave, and so once the recruitment of the follicular wave has been induced, we start stimulating the follicular growth with FSH, and so we, under the effect of FSH, the cohort of follicle is growing homogeneously, and so on the time of collection, if everything goes well, we end up with a nice and homogeneous cohort of follicles of competent oocytes. Now, also, if stimulation is not done properly, what can happen is a scenario like this. So having actually 2 cohorts of follicles, so that are a small one and a larger one, and when we have been following every day the growth of this follicle, and we realize scenarios like that were happening, usually those larger follicles come from the atretic follicle of the previous, so the subordinate follicle from the previous follicular waves. So I'm talking about those one there that has been revived by the FSH, and do not hope getting much embryos from this oocytes coming from follicles that were almost dying during atresia. So in our lab, what we say all the time is that IVF does not perform any miracle, and it cannot restore oocyte quality if it's not there from the start. So what we hypothesize when we OPUs are performed on non-stimulated donors, depending on the time you are going to collect these oocytes, you could have various scenarios. You can if you're lucky, you can have growing follicles. If you're unlucky, you've got atretic follicles. So you've got all kind of scenarios, and under our conditions, and one of the main difference would probably be the number of donors compared with the previous setup from Dr. Castro. We needed to try to limit the variations that we were seeing. So that's another reason we have been using stimulation. So what we are trying to do to perform with stimulation is to basically make the oocyte ready to mature. So, and when we're talking about maturation, we're talking about meiotic maturation, cytoplasmic maturation, and finally molecular maturation. So several types of events that are occurring within the oocytes under a controlled environment of hormones. So now let's talk a little bit about costing, because when we're talking about stimulation with IVF, so stimulation, so it's basically the injections of FSH that we are giving. Then costing is the period of time between the last injection of FSH and the time of collection. And during that time, basically depending on the donors and our programs, but you can see that in the proceeding, basically from 30 hours to 40 hours on average. So during this costing period, the oocytes are undergoing prematuration, so becoming ready to mature then in the in vitro system. So basically here, this cartoon comes from a study that was done at Bovitech in the late 90s. And basically, in this study, so there were 6 animals that underwent, each of them, 4 different costing periods with the same stimulation in terms of FSH. So 6 constant doses of FSH. So what we're seeing is that, so with 20 hours of costing, so the 6 injection, we wait for 20 hours without any FSH, and we collect the oocytes. So we see mainly small and medium follicles. So the green here on the cartoon, sorry, it's a little bit small, stand for 5 to 6 millimeter, and the yellow ones are standing for 7 to 10 millimeter. The red ones 11 to 15. So basically small, medium, and large. So if we increase the costing, what we are seeing is that the follicles keep growing. So we see mostly medium and large follicles at that point. What's happening next when we increase the costing with an additional day is that the follicle do not grow further at that point. It's kind of plateaus. And so what is likely going on is some maturation step inside the follicle. Then, if we add an additional 24 hours, so basically 4 days of costing, which is completely extreme, but that was for the purpose of the study, the follicles are resuming their growth, and we end up with mostly large follicles. So if we look at the blastocyst rates from this study, we can see that we can see 2 things basically. That one of the highest blastocyst rate was with the 44 hours of costing. So the second picture we saw, but also you see the scenario is the less variation, which is very important when you are running an IVF program, because you don't need to have only one donor performing well, but I mean most of your donors, if you can, performing well. So we see 2 things: a high blastocyst rate, so over 60% in this study, and less variability when the proper costing period has been selected. So going back to, I mean, more data and less theory, we looked at our IVF records between January 2013 and July 2015 with donors of at least 12 months of age that were stimulated with dominant follicle removal, first 6 injections of foltropin of 30 or 40 milligrams and 30 or 43 hours of coasting. Our IVF system is very standard for in vitro maturation, intrafertilization. So conventional sexed and reverse sort semen were used in these cases. So and the embryo were cultured in vitro. Then in the outcomes we looked at the number of follicles that were stimulated, number of embryos produced, the pregnancies as well, and with some additional factors such as pregnancy status, antral follicular count, repeated stimulations, and poor or versus high responder. So stimulated versus non-stimulated. In a preliminary study, we have been doing some non-stimulated work for IVF in cows, not in heifers, and we found a significant difference between the two systems. So with on average 42% of transferable embryo rates in stimulated donors and about 20% in the non-stimulated donors. When I'm talking about transferable embryo rates, I mean so the number of embryos, quality 1 and quality 2, out of the total of COCs in maturation. So I'm not including the quality 3 embryo that we are not transferring, that we do not consider are transferable embryos. So general results, we looked at 1,358 OPUs out of 376 donors. So most of the donors were collected multiple times. The average transferable embryo rates was 42.1%. There was no effect of the pregnancy status. Then on the graph on the right, we looked at the size of the follicle stimulated. So with our stimulation, what we see a very small proportion of 1 to 4 millimeter follicles. We rarely aspirate them because I think we are lacking the effect of stimulation in those donors. But then about 20% of small follicles, about 60% of medium-sized follicles, and about an additional 10% of large follicles. So most of the follicle are from the medium category, which was significant. So when we look at repeated stimulation, and what we did, we looked at the donor that we collected 10 times and more, and we looked at the average of the first 3 collections in terms of number of stimulated follicles and transferable embryo rates versus the 3 last collections out of the 10 collections. So basically, we didn't see any difference in terms of stimulated follicles. So again, we removed in these studies the donors that were below 12 months old of age, so trying to avoid any age effect, but no significant difference in the number of stimulated follicles between the 3 first and 3 last collections. and no difference either in the transferable embryo rate between the first 3 collections and the 3 last collections. So now looking at the distribution of the follicles stimulated. Here on the x-axis, these are the number of follicles stimulated. So on the y-axis, the proportion in terms of the percentage of total number of collection we looked at. And what we see that the distribution of this of the number of stimulated follicles is not a normal distribution. It's skewed on the left, which means that there is a higher proportion of donors that are stimulating less than 12 follicles, which was the median of this distribution, compared to donors stimulating a higher number of follicles. So then, when we look at the number of transferable embryos, we have a similar distribution, which expect. So basically, there are more donors producing a few numbers of embryos, and it's very similar to a conventional flush in this regard. 1/3 of the donors are producing 2/3 of the embryos, and those ones that we call the high responders. So the big issue that remains with stimulation, okay, we do increase, we're able with stimulation to increase the rate of transferable embryos. So at the end, also the number of transferable embryos, but still this variability that is quite unpredictable remain a big issue in our IVF program. So we tried to investigate that. So the median of follicle stimulated was 12. We defined a group of low responder, the one that were stimulating less than 6 follicles, so median minus 6. And the other group of high responder that we defined was the group that was stimulating 18 follicles and more. And we tried to identify some differences in our data set based on that. So low versus high responder. Here, so the low responders are the white box, high responder, the black boxes, his bars. So in terms of number of transferable embryos, TE, of course, there is quite a big difference between the low responders and high responders, and this difference was significant. Same thing for the transferable embryo rate. So the difference here is significant between the poor and the high responders. So between the 45 and 55%. Then, when we look at the quality of these embryos, which here we took as a criteria if the embryo were freezable or not, we didn't see any significant difference. So yes, so that, of course, these low responders are producing less embryos, do have a lower transferable embryo rate, so do not convert as well. But once their embryos are produced, the proportion of embryos, of freezable embryos, is not different. So, okay, we'll look at the distribution of the transferable embryo rates between these two groups. So dark blue there is the stand for the group of low responder, light blue high responder, and so what we see here is that the distribution looks different. We didn't do any study on that, but basically the group of low responder is the distribution is not as wide. So when we looked at the failure frequency, so the number of donors of sessions between these two groups that didn't yield any embryo, there was quite a big difference between the low responder and the high responder. That was significant. So it's much more common with low responder to have, no embryo produced. Okay, so we with our data set, so we were still wondering why, and we decided to look at the sizes of the follicles that we were stimulating, and here what we've seen, so same thing, the black boxes for the high responders, the white bars for the low responders, and so what we see, there is a difference in the follicular pattern. So the low responder have in terms of proportion, a number, but less less small-sized follicles and less, but more medium-sized follicles, and that's something we cannot really link then or directly to the rest of the observation. So they do the follicles, the few follicles that they are growing are within the expected sizes we've shown at the beginning of the presentation when I explained with the cartoon of the stimulation and costing. So our hypothesis, and that we will still need to investigate, is that must have something to do with the quality itself of these oocytes, and it goes back to Pietro's presentation earlier on this afternoon. So at the conclusion, in our system, the main limiting factor for donor efficiency with stimulation is the individual variation that we see, a lot of variation between donors that makes the system less efficient, because we can always predict this variation. So we need to better understand the ovarian dynamic of these donors, and there is a lot of research to be done. Also, individualization of ovarians, so personalization of this ovarian stimulation programs and other costing period looks like a very good strategy to apply. Thank you very much for your attention. I would like to thank some people here at Bovitech. So Christian Vigneault, who is the head of research and development, our director, Dr. Blondin, Dr. Rico, who was the postdoc involved with this project, and the entire Bovitech team, because it's really a teamwork, and every single step needs to be controlled in order to be successful. Thank you very much for your attention.